Okay, this is a binomial question for January 2014. It's question number 5. It says use a binomial theorem to express this to the power of 5 in the form of a plus b to the root 6. So it's to do with surds as well. So remember, for the binomial theorem, we use Pascal's triangle and we're looking at the power of 5. So we're using this row here. It's the power of 5 there. So we're going to end up with the power of 1, 5, 10, 10, 5 and 1. We're going to need all of them this time. Okay. Remember, this power's decrease, this power's increase. So we're going to end up with times 1, and we always start with wherever power is, so power of 5. This is the power of 0, so it's just 1, so it's not there. Okay, so 5 times 1 to the power of 4, so this one decreases, and this one increases to the power of 1. This one decreases, and this one increases to the power of 2. 1 decreases, and root 6 increases to the power of 3. Here we go in. 1 decreases to 1. Root 6 becomes root 6 to the power of 4. And the last one, 1 decreases to 0, so you don't include it. And root 6 increases to the power of 5. And we're going to start then. 1 times 1 to the 5 just gives us 1. 5 times 1 is 5, so just 5 root 6. 10 times 1 is 10. Now, root 6 squared, remember, if we have a root times a root, so root 6 squared, the roots cancel just to give us 6. So that would be 10 times 6. 10 times 1 squared is just 10. Root 6 cubed is the same as this, so root 6 times root 6 is 6. But times by another root 6 will give us 6 root 6. Okay, so root 6 cubed is 6 root 6. 2 of the roots cancel out. Then we've got 5 times 1 is 5. Root 6 to the power of 4, so it's basically double this. So we've got root 6 times root 6 is 6. Then another root 6 times root 6 is another 6. And they're all times together, okay, because they're all touching. And then we've got the last one there, which is going to be plus, so I can put plus there, 1 times root 6 to the 5. So it's essentially this, root 6 times root 6, and another root 6. So we've got a times for the root 6 there. Okay, working this out then, we're going to end up with 1 plus 5 root 6 plus 10 times 6 is 60 plus 10 times 6 here is 60 root 6 plus 5 times 6 is 30 times 6 is 180 plus root 6 times 6 is 36. Root 6 is kind of like every other number, isn't it, in a surd. And that's our final answer there. Part B then says the coefficient of x squared, this is an n question, is 495. Find n given that it's positive. So this is where we use again this equation here. This will be given to you in the exam. So we look at the part in front of x squared, so this part here. Okay, and the first thing you do is write that down so they know that you've got that in the exam there. Okay, so we write that down. This is part B. So we had n minus 1 over 1.2 x squared. That was the part in front of the x squared. Okay, and this is 495. I won't put it there yet, actually. Okay. Now then, we need to look at the question, because often it's not just x, this number in front of the x. So this time it's a 3x. It's not just x squared. We need to put it down as n minus 1. This is going to just become 1 times 2 is 2. And this is 3x squared. So make sure you put that in a bracket. It's really important. It's not just x. We're looking at 3x. So this x becomes this 3x here. Okay. So if we work this out here then, we've got n squared minus n over 2 and a bracket. 3x squared will give us 9x squared. Now we can go back up to the question, and now we've used the formula. It says the coefficient of x squared. So all it means is the part in front of x squared. So we're looking at this part here. Okay, and this part is 495. So we can put that, so n squared minus n times by n over 2 is 495. Okay, we need to bring this 2 up and multiply by this 9. So this is going to end up with 9n squared minus 9n is 495 times 2, which is 990. Now we're starting to look at a quadratic, which we normally do. So move this over, so you get n squared, 9n squared minus 9n minus 990 equals 0. Divide by 9, so we get n squared minus n minus 110 equals 0. And then go on and factorise it. So you can do add to make minus 1 times to make minus 110. So I'm going to do n and n plus and a minus plus 10 minus 11. So my two values are n equals minus 10 or n equals 11. But it's positive, so we take the n equals 11 as our answer there.